Hello and welcome back. Um, this is going to be the last video I do for the Star Cut for a little while. I've reached the limit of what I've studied so far, what I've played with, and I wanted to share it before I get into the books and start trying to understand what else it can do and where it shows up in different architectures around the world. Um, but what you see before you is a circle. I drew it my usual way with two seeds, 90 degrees angles to each other, so that I could find this center square. And then from there, I used my compass to mark out the length of one of these lengths of the square to give me four more. Okay, one, two, three, four around the outside. I did that because I want the distance to be equal. So this distance is equal to this distance is equal to this distance, and same going left to right. Um, sorry, I'm saying an awful lot. I've also got a star cut here for reference. Okay, this is just here because I want to have something visible that I can do or I can see to use as a map. Because what we're going to do is imagine that there are three squares here, not just one. The first square is going to sit on top and just sit here. The second square is going to be stretched, okay, to the full length of this rectangle. And we're going to stretch it. And the third square is going to stretch up and down again to the full length of the rectangle. And because of the way we measured it all out, this rectangle is the same length and width as this rectangle, right? And we are going to, obviously I can't stretch it on the paper, but we're going to draw the star cut as if it was also stretched across the entire width of the shape. Okay, so as before, we would go midpoint to midpoint. And bear with me as I do this. I want to rush so that you don't have to painfully sit through and watch it, but I don't want to rush because that's when I make mistakes. And I really don't want to make mistakes because it takes a while to set up this little template. I need to design these a little better. Something I can draw over maybe. Okay, what we're seeing is the star cut stretched as the rectangle stretched. And I'll probably shut up and concentrate. I've already screwed this video up once already. All right, one down, one to go. All right, let's take a look at what we got here. Straighten back up. So our star cuts are now laid over our center square. And what immediately becomes apparent to me is we have 4 points at the midpoints of the edges, and we have these 4 points with many intersections in the middle. And it's these that I want to draw our attention to. First thing I'm going to do is draw like there's a square here that's implied in the middle, so I'm going to draw it in. And this is just connecting the midpoints of our original square. It was always there. We could have done it at any point. It's going to help illustrate what emerges from the center of this diagram. Okay, so let me just highlight that for you because there's a lot of lines going on here. And I'll use this color. Okay, so here's our square hiding in the middle. Like I said, this wasn't originally drawn in. It's implied just by the fact that we know where the midpoints are on the original square and circle. And this one essentially shows up as a diamond inside our original square. Okay, yeah, you can see that better. Now, what's interesting here about these points, these 4 points that show up around the middle, is you can use that to draw a circle. And that's what I'll do. Okay, if I take my compass from the origin to the point at the top of those, I guess triangles is what they are, but those intersections, let's make sure I'm in the ballpark here. And we go around our square. It looks like, I'm going to emphasize the word looks, like we might have found a squared circle in the middle of this. And I'm skeptical. Mostly because when I do the math on this, it doesn't quite line up the way I expected it to. But it's interesting, and it's curious that it would show up in the middle of this diagram anyway, in my opinion. But when I do the math on this and measure the length of the square versus the circumference and area of the circle, I end up, and it changes, I mean, depends on how accurate your picture is, but I end up with the perimeter of the square equaling the area of the, all right, it said that backwards. The area of the square equaling the circumference of the circle. I'll repeat that. The area of the square equaling the circumference of the circle. And if I do it right, I usually get within 1/10 of a centimeter. And again, it depends on how accurate you are, where your lines are going. You can see I've got a couple lines here. They're just a couple millimeters off. So I mean, this could be nothing. This could be absolutely nothing. In fact, I have, normally it's you want to make the area of the square equal the area of the circle. And I have yet to be able to do that with this method. But it seemed curious. And it's interesting that it shows up here. I'm wondering if a little bit of tweaking, I don't know whether the lengths need to be different. I don't know if it's a matter of the type of cross or or whatever else. But yeah, I like that it's there. I don't know, it gives me some sort of hope that there's more to find here, and of course there is. But it's very, very interesting. to me that this shows up here. I wasn't expecting it when I first started playing around. But yeah, it's there, whatever it is. I'm not saying it's a squared circle, but it's not too far off. And pardon me, I'm so sorry for coughing in here. It's yeah, it's worth investigation. Another neat thing that I like about this design is the flower, which I've left here because I really like the fact that there's a flower in the middle of this. It lines up with the edges of the square. You can see that the geometry measures up so that one of the square equals the same intersection point of two of the petals, and then the other one does the same thing on the other side, which I think is kind of cool. I like it when the circles and the lines line up in these little ways. Yeah, and there's not much else I can say about it. This is about the limit of my discovery here. Like I said, I've got a book. It's Malcolm Stewart's Sacred Geometry of the Star Cut Diagram. So I'm going to be digging into that to see if there's any answers there, and what other answers about this specifically. I know there's other answers, but yeah, I want to dig in and see what else is going on in here. So anyway, that's how far I've gotten with this, and I'm most curious to see what else there is to discover. You guys stay well, and I will talk to you soon.